and welcome to everyone that's joining. This live session is about GCSE Maths. Okay, we are going to begin shortly. I'm just waiting for everyone else to start joining. Okay, we are just going to go ahead and finish this grade 7 to 9 higher GCSE mini test 2, hopefully, in this live session. Okay, thank you for the shares. Keep sharing, everyone, double tapping the screen, liking. I know the GCSE results have happened and everything, but this is just going to be good revision for you if you are in year 10, even in year 9, going ahead into the GCSE Key Stage 4 years. Okay, it will be very good for all of you. If you want to take part, of course, feel free to leave your answers in the comments. We're going to start with question number 16. If you want access to the previous questions and how I did them, you can check them out on YouTube. So I've uploaded all the previous live sessions I've done for this paper on YouTube, so go ahead and check that out. My YouTube is the same name as my TikTok, so it's the Traditional Tutor. Okay, and there you can get detailed solutions of how I ended up completing all of these questions previously. So somebody just said, my friend Aman struggles with this, any tips he's getting used? Okay, if that's the case, definitely if you sort of get him to follow me first of all, so that he can attend the live sessions. And I would also say that, you know, get some extra tuition as well on top of you, of course, attending your classes, doing your homework, etc. But put in some extra revision as well. Okay, so forgot to mention, I'm also a maths teacher. And I am also a tutor as well, so if anyone needs tutoring, you can get in touch with me for that as well. Okay, and we're going to begin with question number 16. Okay, so question number 16 is starting off with prove algebraically that the recurring decimal 0.135 and only these two digits, so my 1 and my 3, is going to be recurring. Okay, because the recurring dots are on top of those. So the way this would look like is as follows. I'll write it down. It would look like 0.135 135 and 135. Okay, now I know that the recurring dot is not on the 3, but the way recurring decimals work is if you've got a recurring dot on the first digit, so 1 after the decimal point, and another one on top of the 5, then whatever is in the middle of those two digits, okay, they are going to keep repeating as well. So it's kind of like, you know, the start and the finish, and whatever's in the middle also sort of stays. Okay, and it keeps repeating like that. So now our job is to prove that this can be written as 5/37. Okay, so we are going to follow a few steps of how to go ahead and do this. If you know, let me know in the comments what might be the first line to show this proof. Now some of you might know, some of you might not, as this is quite really higher level stuff. Okay, I'll say something that you get taught all the way in year 11 mainly. If anyone's got any sort of suggestions, let me know in the comments. Okay, so the first step that we're going to do is we're going to use a bit of algebra. So whenever proof comes in, we do like to use a bit of algebra to make things easier for us. So we're going to let x, now you could choose any variable like x, y, z, whichever one you want, and we will numbers. Rose Sunshine, welcome. How are you doing? Have you been in the meditation that I mentioned to you? Yeah, this is a different sort of live session I'm doing, walaikum salam, on maths. Okay, this week I'm so sorry I haven't been able to do the meditation one. We will get onto that next weekend. Okay, life just happened and got quite busy, so definitely next weekend we'll be doing that. Yes, it worked, thank you, bless you. Oh, that's brilliant. Keep it going then. Keep it going, and inshallah you'll see even better results as you keep doing it consistently. Okay, No problem. I mean, thank you. Okay, so what we're going to do is we're going to let x equal. Oh, it's a spider or something on my paper. So we're going to let x equal to this recurring decimal. Okay, so I'm just going to rewrite that again. 0.135135. And that's it. I'm just going to show that it's repeating with the 3 dots like this. And then what we're going to do is we're going to sort of think about how I can multiply this 0.135135 by a number, okay, so that my all of my repeating side stays on the other side, and I basically want to get my other digits onto the other side. So the way this works is I'm going to multiply x by 1000x, okay, because this recurring decimal has got 3 digits in it that are recurring, so we want to multiply it by 1000 so that the decimal points move once, twice and 3 times to the right, okay. So that means I'm going to do let 1000x equal to 135.135, etc. It's going to keep repeating like that. But what that does now is it is going to really help us cancel things out, okay. So then I'm going to do the 1000x minus my x. So I might grab another piece of paper. So on here, if I show you question number 16 in a better way. Meanwhile, if anyone has got any comments, I will be referring to them as well. So I'm going to get question number 16 up here. So I had we had let x equal 0.135, oops, not 0. And then 135 and recurring as so. And then we had let 1000x equal 135.135 and so on. And then what we're going to do is subtract the 1000x, the x from the 1000x, okay. So I've already got the 1000x there. I'm going to put down x again, which is equal to 0.135, and I'm going to line it up as follows, okay. That's very important that we line up the decimal points. That is where we can often make a mistake, okay. If you're so far following along, double tap the screen if you've got any questions. In the meanwhile, let me know in the comments, okay. And yeah, I've just got some Vaseline on my hand, which is why it's looking very shiny and sort of slippery, but yeah. So I'm going to be subtracting these two, so I'm going to write it down like this, okay. Subtracting as follows. These two are going to now cancel out, okay, because it's the same repeating part of my recurring decimal that's going to keep going on here, even the dots, okay, because it's going to be the 135, okay. So far, if it's looking good to you, double tap the screen if you are understanding. And what happens here now is the other parts we're just going to subtract as normal, okay. So I'm not even going to put the decimal point because there's no need. It's just going to be an integer that I'm going to have. So 135 minus nothing is just going to be 135, okay, with nothing here. That's what it is. So therefore we now know that if we have 1000x minus x, it's equal to 135. But what happens here is we're also going to be subtracting the 1000x with the 1x, okay. Now we don't really write down 1, but it's always just understood that is going to have that x has got an invisible sort of 1. It's called a coefficient, the number that you multiply the variable by, okay. That is always going to be there. So now we're going to just subtract these. 1000 minus x is going to be 999x, okay. And then the last step is we're going to divide now, and this is now just going to be a case of normal rearranging your equation, trying to just get x on its own, okay? So then hopefully you'll be left on the right side with a fraction, which is what the initial question asked us to do, okay? And so I'm going to divide both sides by 999. Divide by 999. 9. So it's going to be 135 over 999. And therefore x is now going to be equal to this, which again I think you can put on the calculator because it is such a sort of big number. Hopefully this will be on the calculator paper. Even if it isn't, we can always do our bus stop on the side, okay? But for now, I'm just going to do it on the calculator, and I do end up getting 5 over 7, okay? So that is the answer to this part. Okay, let me know if you've got any questions so far, how it's going. What degree, please, you study? I did maths, okay? Pure maths as my degree. And alhamdulillah, got a good first class honours degree in maths, hence a maths teacher. Okay. Right, sorry for the shaking. A maths teacher. Okay. Right, sorry for the shaking. Okay, so now question, a maths teacher. Okay. Right, sorry for the shaking. Okay, so now question of cone is area of cone B. So straight away when you have this sort of question, you should be getting some sort of signals that this is a similar shaped question. So you're going to need to use those rules from that topic. Anyone got any ideas what we do when we have two similar shapes? And what are similar shapes exactly? So these are my sort of key words, and I've got the height I've been given is 12 centimeters. Height of cone B is 8 centimeters. I've been given the surface area of cone A, 60 centimeters squared, and I need to work out the total surface area of cone B. Okay, yeah, let me know in the comments if you have got any sort of idea about that. What might be step 1? Okay, moves to this live. Yeah, and I've just got some sort of goal up there as well. So if you want, you can help me achieve that goal. If not, that is completely fine. You can just be around to answer all of the maths questions. If only I could see the comments of people. Where's the comments gone? Okay, so I'm just going to make a start now on question 17 here, okay? And I'll do it on the other piece of paper, so mathematically similar shapes. Question 17. It is asking us about, so it's been, the first thing that we can do is work with the sort of knowledge that we've been given. So we've been given the height of both of the cones, okay? Cone A is 12 and cone B is 8 centimeters. I don't know if you can see it. Okay, it's better. So what we can do with similar shapes, it just means that it's the same sort of shape, but they've got one is slightly larger. So if you just think about sort of what shape might be a better idea. Currently I have got 2 pencils. Okay, so I've got 2 pencils, okay? So now pencils mathematically, you know, they have pretty much the same sort of shape because they are both pencils. So, you know, HB typical pencils, the same sort of shape, yeah, okay? But the difference is that they are sort of different. If I move this up slightly, okay, they are sort of different in their surface area, in their heights, okay, and in their ratios basically. So this one is smaller compared to the orange one, which is slightly bigger, but it's essentially the same sort of shape. So mathematically similar shapes just means that they are the same shape, but they've got different sizes. So they are, you know, similar by a certain ratio. Now that ratio could be 5, 6, 7, 2.5 even. The way we can work that is if we know the height of the orange pencil, I can take that and divide it by the height or the length, any sort of what do you call it, any sort of I've forgotten the word, any parameter, yeah, that we sort of know about that shape. So if I know the height of the orange, I can divide that by the height of the brown pencil. That way I'll know the ratio in which they are both related by, and then I can use that to work out the surface area, let's say, or the length of the shape, the width, etc. Okay, so we're going to do exactly the same now with my cone A and cone B. Thank you for the likes and follows, everyone. Keep liking as well. And thank you for the shares as well. If you have any questions on the way, let me know in the comments. So I'm gonna divide now the height. So cone A divided by cone B is what I'm going in the comments. So I'm gonna divide now the height. So cone A divided by cone B is what I'm going to do. It is going to be equal to, so cone A from the question I know was 12 centimeters. That's the bigger one. I'll divide that by cone B, which is 8 centimeters. Okay, and that way I'll know that the surface area, can leave it as a sort of fraction. I sort of prefer those, and if I can just sort of do it like that by just looking at the common factor between them, and that's 4. So that means 12 divided by 4 is 3. 8 divided by 4 would be 2. So it's just 3 over 2. That is my ratio. Okay, how are we doing so far? Double tap the screen to let me know that you are following along, understanding, and also if you've just joined, please help me achieve that goal that I've got 10 minutes for. Okay, and also, yeah, if you want to subscribe, then please click the subscribe button. You can have really cool perks if you become a subscriber. We can do subscriber only lives. You can pick the topic, and I can really make it for your sort of according to your needs, okay, at a very, very reasonable price as well per month. So definitely check that option out as well if you're interested in like more in-depth maths sessions with me live. Okay, okay, so I've got the ratio now, and the area, sorry, the surface area, the way that works is, so the surface area, I'm just gonna write down SF of A, we knew was 60 centimeters squared. Okay, now to work out the surface area of cone B, okay, which we don't really know yet, what happens is with surface area, the ratio is not just going to be 3 over 2. Because surface area is a different sort of measurement, it's in squared units, we are actually going to be squaring it. Okay, so what we're going to do is take the surface area of A and actually square and multiply it by 3 over 2 squared. Okay, so multiply it by the ratio, which will be squared. Reason being, like I mentioned, surface area is a squared measurement. Okay, it's not just a normal measurement of, okay, 12 centimeters, or in this case 60 centimeters. Let me know in the comments if you've understood that very important point, because that's often what students forget. They work out the ratio and think, okay, I'm just going to multiply that by the surface area and hopefully things should be fine. But no, because we've got to remember to be multiplying it that way. And actually, we're not going to do that completely because what I have, and another thing I've just noticed is, which I was going to do wrong, is I'm actually going to divide it by 3/2 squared, okay? Does anyone know why I'm actually going to divide the surface area of shape A by the ratio that I've just worked out? And I'm also going to square that as well. If you know, let me know in the comments. So if you also notice, you've got the measurements there of cone A, so it's the height is 12 centimeters, okay, and cone B has got a smaller height of 8 centimeters. So why do you think, if we're working out the surface area and we're going from shape A to shape B, we're going to divide rather than times by the ratio? Okay, I'm going to explain that. The reason being is because we're going from a bigger shape and we're going to a smaller shape, that is why we're going to be needing to divide, okay, instead of multiply. And that's also very important. So you need to read the question very carefully and see which one is the bigger shape. The hints will always be in the question, which one is the smaller shape. So we're actually going to divide by 3/2 squared. And if we actually do 3/2 squared, that is just 3/2 times by 3/2, which becomes 3 times 3 is 9, 2 times by 2 is 4. So I'm actually going to be doing, if I give that, I'm actually going to be doing 60 centimeters divided by 9/4, okay? Now, if we remember how to do division, there is a special sort of acronym that we often teachers come up with for that. If you know, let me know in the comments. How do we divide with fractions? So you might all remember the KCF method, keep, change and flip. So we're going to keep the first number as it is, as 60, flip the sign and it becomes times. Sorry, change the sign, it becomes times, and flip the last fraction, so it becomes 4/9. Now when I do that, I can easily sort of cancel out my numbers within the right thing. So we've got to think about these. This will become, they will both go into the 3 times table. So this will become 3 here, this here will be becoming 2. So 60 divided by 3 is going to give us 20, okay? So now I've just got to do 20 times by 4 is 80, and the divided by 3 stays as it is. I can't really seem to simplify that any further, so I'm going to leave it as it is, okay? If you are understanding it so far, let me know in the comments, everyone. And I'm also just going to check on the calculator what that turns out to be. So yes, it is 26.66. Yeah, so it equals 26.6 recurring centimeters squared, okay? Because it's surface area, it's going to be squared. Welcome to everyone that's joining. We are just taking a look at GCSE Maths paper, higher GCSE Maths mini test. Okay, so we have got this now. And what we are needing to do is yeah, so this is going to be the answer. Yeah, the other thing I was thinking about, an important point is to let you know about, is another way we can check that my answer is sort of correct is, now that we know, we've established that cone A is bigger than cone B, depending on the, you know, based on the measurements that have been given with, we can sort of also see that the surface area that we're going to work out of B should be smaller, okay? If it's not smaller, then that's going to be giving you alarm bells that you've done something wrong. For example, if this turned out to be 80 centimeters squared, then definitely you've gone somewhere wrong in your working out, okay? This value should definitely be smaller if you know, the shape that you're sort of working with is the smaller shape, okay? So yeah, we've done that question, and I'm going to leave it as 26.6 recurring centimeter squared. Now we've got a prove question. Keep double tapping the screen, everyone, if you are understanding and enjoying the live session as well. Okay, and let me know who's looking forward to going back to school. Also, if you are liking the live session and really finding it helpful, give my account double taps and also subscribe to my channel. Not my channel, my page. And also I'd recommend you to become a subscriber, join my community to attend the subscriber only live sessions, and amongst many other perks as well that are of becoming a subscriber. So definitely check those out. Okay, we're going to move on to question number 18. So we've got to prove that triangle ABD, so this triangle here, is congruent to triangle BCD. Now it's very important to know which triangle they're talking about and also what is congruence. Now if anyone knows what there are about 5 congruency rules or criteria that we sort of follow to prove that two shapes are actually congruent. Okay, now similar shapes and congruency, often people get mixed up between them, but congruent is basically the same shape, either sort of turned, twisted, etc., but it is identical. They're both the same shapes, as we will notice when we are proving this question. So the way we are going to be doing this is, first of all, write down all my congruency criteria. So I've got the RHS rule, side, side, side rule, SSS, angle, angle, side, angle, side, angle, and side, angle, side. Okay, now these 5 are my congruency, just like to say, criteria. Okay, this is my congruency criteria, everyone. The 5 sort of rules that I like to use. Now I can, if these two are congruent, I should be able to apply one of these rules and be able to prove that yes, it does work by one of these. Okay, so RHS, what that means is if that's for right angle, so if the two shapes have got a right angle, a hypotenuse, and one other side that is the same length, okay, then we can tick the box there. Now in this case that won't really work because we don't really need it. I mean, it's not right angle. The other one we could use is if all side lengths were given, but in this case they aren't. We've got more angles, so we can't really use that one as we haven't really got all 3 sides there. We could now use one of these perhaps. So we've got angle, angle, side. That means 2 angles and a side that's not in the middle of them, that's not included. Okay, that means it can't be this side length because it's in between the 2 angles. It can't be that. Okay, similarly here, it can't be this side. We're just talking about 2 random angles, 2 angles, and 1 non-included side. Okay, so that's what that one is. The 4th rule is angle, a side in the middle, and then angle. So that would mean that yes, this angle, the side here, and this should be the same. But as we can see, we've got 83 is the only common angle, 56 is not here. It could be perhaps this angle, we don't know. And yeah, we don't know whether this side is equivalent either, so we can't really use that rule either. And then the other one is, so I'm gonna sort of get rid of this one. That's a really good way to sort of know which ones you can use and which ones you don't really need. The last one is side, angle, and side. So that means one side, okay, the angle's in the middle, and then another side. So for example, it could be this side here, that's common, angle, and this side, that's what we're hinting, is going to be common. So side, angle, and side. Okay, so that's how that sort of criteria works like. And and now it's just our case to find out. We've got these two now to think about, okay? Sometimes the answer is straight up right there in your face where there's not much to work out, but here we can see we've only got one common angle. The other thing we can do is work out what this missing angle is going to be for this triangle and also this triangle. Now the first triangle ABD, we can calculate the missing angle by just our normal triangle rules, that all angles in a triangle are equal to 180. So we can do 180 minus 83 and 56, and that should be getting us to, if we do that calculation, should be getting us to, I have done it somewhere on the notes, let's just do it from scratch. It's got 10 minus 3 and 6 is going to be 1. 7, so 17 minus 5 is going to be 12. 12 minus 8 minus 2 and minus 6 is going to be 4. So yes, it's going to be 41 degrees. That means this angle here is actually 41. Now that is quite helpful because now we've got two similar angles. We've got 83, 83, and we've got 41 and 41. Okay, we're looking a bit hopeful now. It's looking like we could use one of the angle rules, okay? Welcome to everyone that's joining. We are currently taking a look at, oopsie daisy, this GCSE, higher GCSE mini test, okay? If you're understanding it so far, give the screen double tap. If you have any questions at all, let me know in the comments. Just checking the comments before I carry on. What have we got so far? Okay, if you know what might be next, let me know in the comments. Okay, so I'm trying to prove that these two angles are triangles are congruent. Okay, so far I've found that two angles are common between them, but I need to know which side I can use, which will be the same in them. So I've got if I do the angle side rule, so that's angle and a non-included side. Okay, so yeah, I've got two angles and perhaps this side is not included in between them, so I could use this. Now for triangle BCD, I've got angle and yes, a non-included side. Okay, so perhaps that would be the best one for now. So angle side, everyone, is what I'm going to go ahead with. That if I use that criteria, I can prove that these two triangles are congruent. So, but I can't leave it as that, like that. What I'm going to do is write a bit of an explanation. So question 18, the two triangles, oops, you could have even used one of the other rules as well. Okay, but for now I'm going to go with this one. There is often more than one rule that we can see, or and it's just whichever one you can spot first, okay, because they both end up giving you the right answer. The two triangles, sorry, are congruent by the, I'm going to say AAS rule. Okay, welcome to everyone that's joining. Feel free to always take part, double tap the screen and follow my account as well, okay? By the rule, because, and I'm just going to give you the explanation, because and the angle notation. So angle DAB, I'm going to say is equal to angle, so I'm talking about the 83 degrees here, okay, is equal to BCD, this 83, angle BCD, and angle, which other one, ABD, so 41 is equal to BDC, angle ABD is equal to angle CDB, we can say. If you're not unsure about how I'm doing the notations, let me know. Why is it sideways? Welcome, Safa. Apologies, the reason it's sideways is... Oh, somebody else. Naya joined. She said you waved at Inara. Oh, sorry, did I wave at you? Oh, don't know how that happened because I've been writing. Yeah, reason it's sideways is because I'm just writing it in that sort of way. So yeah, I didn't notice. So apologies, I'll keep it straight. It's just how I sort of write as I get to the end of the paper. Thank you for the follows, Safa, and whoever is liking, thanks for that. Oh, it's Safa. You got a dentist sign. Are you studying dentistry? Nice to see dentists on my live. Yeah, keep the lives coming, and if you want to take part, let me know, inshallah. Okay, I wish you all the best and may become a really good dentist. Okay, so as I was just finishing that up, I've proved that the two angles are equal, okay, in my explanation. The last thing I need to do is prove and just show them in my answer that they've got a common side in them, okay, because of the angle side rule. So that means it's this side, and the way we notate sides is by just reading the corners, okay. So it's D to B, so I'm just going to say length dB or side dB, okay. So I'm going to say the two triangles are congruent by the AS rule because angle DAB equals angle BCD and angle ABD is equal to angle CDB. And I'm going to say, instead of just saying side or anything, mainly what you need to write down is just the common side length. So that is dB, and dB, I'll say, is common in both triangles. Now that's a very lengthy sort of explanation, but the more you write the better, just so that you leave no sort of scope for missing out any of the important stuff, because as well as you understanding it, you've got to have the skill of conveying that you have understood it in your response, okay. Right, so that is that, no problem, Safa. Okay, so we've done that question, the congruency one, and now we've got two more to do. The quadratic one, now that is a bit of a long one, and the sketching one is actually quite straightforward. So I am just wondering, I will just finish off with question 20. If you want to know question 19, I might post a video of that on my TikTok as well as my YouTube shorts perhaps, so you can check that one out now, because I'm just conscious of time for myself. And for you all, should be sleeping by now. But yeah, this is the only time I get to do my lives. So yeah, that's why I'm doing it a bit late than normal. And yeah, the other thing I'm going to do is just finish off with question 20, okay? So sketching the graph of y equals cos of x. So anything sketching, what you need is a sharpened, nice pencil, ruler, and even a rubber, in case you make mistakes. I really don't like it when students draw with the pens, okay, because if you make any mistake, it's really hard to sort of get rid of that, okay, and it makes it look very, very messy. So what we're going to do for the graph of cos of y of x, going to first draw our x and y axes. So that's my y axis, this is my x. And the reason I'm drawing it in such is because we are not really going to go into the negatives. They've only told us to go from 0 to 360. So I don't have to go and show my negative signs. So it's going to be, this is my 0. This is up to my 360 degrees. That is my x. Along the corridor, up the stairs is my y. Now, to actually think about the cos x graph, you need to be remembering the key points. And another thing that might help you, if it's on a calculator paper, and if you don't remember your trig values of cos of, for example, 0, cos of 180 degrees, etc., your calculator will really help you to sketch this graph, okay? Reason being, you can just work out what is, for example, cos of 0 degrees, okay? And remember to put your calculator into degrees mode so you don't get it wrong. Okay, so it's told me it's going to be 1. And funnily enough, the graph only goes up to 1. That's the height of the graph, okay? The cos x graph does not go above 1. in the y direction. So that means when it's at 0, it's going to start at here. Okay, instead of starting at 0, it's going to start here. That's the difference between my cos and my sine graph. If you're understanding it so far, share it with others, like and subscribe, not subscribe, follow my account. Okay, thank you, Amy, sharing the live. So I'm going to start from there, and then the next thing I'm going to do is actually write out my other x values, because I can again plug them into my calculator. This is why calculator is so important. If you know what you need to do with the graph, and if you don't remember the shape of the graph off by heart, that's completely fine. Okay, if it's on a calculator paper, otherwise you need to know the shape. So I've got my 90 degrees, I've got my 180, let's say would be about here, yeah, 180 degrees, and then my 270. So these are the key points that I need to sort of know, and again I can use my calculator, so I know the peaks and the is it called troughs? Peaks and the lows of the graph, okay, or troughs, I think. So we're gonna start at 1, okay, that's cos of 0. Next thing I can do, if I don't remember the shape, but I do of course, but I'm just showing this to you to help you out, cos of 90 is 0. So I know when I get to 90, I need to get to 0. So it's gonna, the curve, it's gonna look something like this. Oops, and I've made a mistake. This is where the rubber comes in very handy. Okay, so sketching is always something I find a bit tricky. Okay, I'm gonna leave it there, and then if I write down cos of 180, so I know where does it go, it goes to -1. Okay, so yeah, that's also something I need to draw on my graph. -1. So now it means at 180 it's got to be here at -1 degrees. Okay, so that's where my low point should be. And then I think you might get the idea. It is a symmetric sort of graph. So cos of 270, let's just check that before we do our sketches. It's 0. So I'm gonna just put a mark here so I know I need to get there. So a good idea, before I even did my sketches, I should have just put the points. Okay. Next is gonna be 360. So cos of 360 is going to be 1. So when I get to 360, it's gonna go up to 1. So up to 190, 180. Double tap the screen if you are following along and understanding this, okay? And let me know if you already know the shape of this graph. I'm gonna get up to 270. Okay, not bad, but I'm just getting my shape to look a bit nicer than that, aesthetic. Okay, so that's all it is, because we only wanted it from 0 up to 360. So I know it looks a bit unfinished, whereas if you compare it with a sine graph, it's a bit more of a finished look. Okay, it just goes to 0, but for 360 up to cos of x, it's just gonna go, for the cos graph, it's just going to go up to 1. Okay, and that's it. We're gonna leave it there. Everything is labeled, the graph is there, and that's all. And remember, question 19, I'm going to do a separate video on that. Okay, so keep a watch on that on my channel, on my page, sorry, and also follow me, subscribe me on YouTube. I am also with the same name on YouTube. And yeah, I hope you're all looking forward to going back to school. Let me know in the comments or even inbox if you have any particular questions. If you require tuition, let me know and I can arrange that. Also become a subscriber to my page so that you can join in the subscriber only live sessions. All right, until then, I'm going to get going. Thank you all for joining in. thank you, Safa. I just read your comments now. You'd get more views if it was straight. Okay, thank you everyone. I'm going to get going.